Now look at here. If you see the flow, it is moving along with the tube. Tube is semi-impermeable. Tube wall is semi-impermeable in nature. But the flow direction is along the tube, along the media. Tube is the media. Okay, so flow direction is along the media, not across the media. Okay, it is along the media. And yes, yes, along the media. Whenever it flows along the media, in the plane of the media, then it is tangential. Whenever it is moving across, like in drum filter, as I shown you, it is the liquid is moving across the filter. Then it was a dead end filter. Okay, now here you can see this is the inside to outside. So this one is a, in fact, the back washing. I am not going into that, but mainly if you see from here, okay, here the situation of dead end filtration, because the fluid is flowing across the plane of the media. Okay, so many cases we use the dead end filtration. Okay, for example, cake filtration is possible through dead end filtration only. And another filtration is the cross flow filtration, or this can be also termed as tangential filtration, because it is moving in the plane of the fabric. If you see, the fluid is flowing in the plane of the fabric. So this is the membrane I am showing. Okay, this is the membrane. Okay, and permeate is coming. Okay, because it is arresting the solid particle. Okay, the solid particle size will be very small, so it is arresting the solid particle. It is allowing the water to permeate through membrane. Okay, so this thing is quite different, because in the case of tangential flow, cake formation not possible, whereas in the case of dead end filtration, cake formation is possible.
And the static filtration, which one the static voltage?
Which one is?
Static filtration. Why the name? One is static and dynamic.
It is the different name is given. Otherwise, static filtration means basically, I mean, the solid particles are static. It is not moving. It is not dynamic. Okay. So in reference to the, I mean, solid particle, it is termed as static. So different name is given. For example, tangential, you can also name it as the tangential filtration instead of cross flow filtration. Yes. 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 Cross flow, tangential, these are same. We are giving different name, but these are same.
In this case, the amount of impurities which we are going to filter is very, very less.
Yes. Because that's why I told you earlier, because contaminants level must be very low. That's why if you are going for ultrafiltration, reverse osmosis, initial phase you will have to remove the large contaminants, and maximum possible removal of contaminants is required. That is why it is in the line. Filtration is not a single step process. Initially you can have the separation followed by filtration, so there could be multi-step process. For example, filter press you are using. Okay, so in a typical setup you can have filter press. After filter press also you can have this ultrafiltration. Depending on the where you will be using the water, whether the water will be reused or what will do with the water, whether the water will be thrown out. So based on that, basically it is decided. Okay, based on the next phase of application. Yes, cross flow means it is perpendicular to the plane of the fabrics. Like some of the video I've shown you, the drum filter case. Okay, cake is formed. Okay, so fluid is flowing in the perpendicular to the plane of the fabric. So that is known as cross flow. So cross flow filtration may have the blocking filtration without cake formation also possible, just like the blocking filtration, because if the contaminants is very less, for example, if you want to remove the virus, bacteria, so very less in number, so you may not have the cake formation. So it is not that in always in this case you can have the cake formation. It all depends on the situation. But here in this case there is a possibility of cake formation also. But this case there is no formation of the cake formation. So this case you can have cake formation and without cake formation. Both is possible. Both the picture I have shown you. Yes, cross flow you can have, for example, contaminants are very less, In that case also the people can go for the cross flow filtration. For example, separation of bacteria, virus, you can have the cross flow filtration, and that will take lot of time, okay, to saturate the media. So in that case you can go for cross flow filtration without cake formation. So in this case cake formation is possible, without cake is also possible. In this case there is no possibility of cake formation, because it will be completely shear out all the time. Because of the fluid flow, the cake cannot form, it will shear, okay, because it is flowing in the plane. So proper cake formation not possible in the case of cross flow filtration.
And sir, if you compare the flow rate of dynamic filter media and static filter media, which one have a higher flow rate?
No, that all depends on the requirement. See, what contaminants you want to remove. As I told you in my earlier class also, if you make the material very compact, okay, obviously you can remove very small size particles, but throughput will get affected. Okay, pressure differential will be more, throughput will get affected. Okay, so it depends on the requirement. Requirement is different from place to place. Okay, if you are having large particulate matter, for example, you are using this one. This one can be used for removal of debris. Suppose you are going for fishing culture. For removal of debris, you can use this material. So large, okay, the pore size is quite large. Okay, so it can remove the debris. Why to make it very compact? The compact material is not required. Okay, so in that case, all depends on the size of the particulate matter. Okay, their concentration. So lot of parameters that also I discussed in due course. So it all depends on the size of the particulate matter. If you want to capture the virus, bacteria, okay, ionic matter, for example, in reverse osmosis, why you need so much of high pressure as compared to ultrafiltration? You need very high pressure in the case of reverse osmosis, because the ionic matter you will have to remove. That could be smaller than virus, bacteria. That you want to remove. That's why you apply very high level of pressure, because nothing comes out free. Reverse osmosis obviously can remove something, but at the cost of energy. Okay, at the cost of energy. So whenever we are talking about finer particulate removal, that become always a challenging. Finer the matter, okay, it will be more and more challenging to separate. Okay.
Another query is, when we are using a RO filtration, so all bacteria, virus were removed.
Yes.
But domestically, when they supply, companies supply RO system to home, they are providing ozonizer or some UV type. So that I think that these kind of system makes no sense. When viruses are already filtered through RO, then we are putting any UV.
Yes, see, that will not be so much effective, but this is also the publicity.
No, sir. So, here what happens in case of RO, reverse osmosis, RO remove all the ions, so TDS will be 0. But we need around 100 or 200 TDS. So what happens? They bypass the another stream, and the another stream RO is not working at all. So over there we use UV filtration, so bacteria can be killed. I hope.
No, whether there is another challenge to remove.
No, sir. So what happened in RO, the stream, like we are having 200 TDS, for example. So 50% for, if my target is to reduce the TDS 200, then 50% I will pass by RO. So then it will be 0, TDS will be 0, and 50% I will pass, that is having.
Okay, so that is the difference. They are combining these two. Ideally, RO can remove, all the viruses also.
Everything.
Okay, but ideally that RO should remove. But as you are using combination system, obviously the combination system is giving a different feature altogether. This is the combination system. So in continuation of my last class, now pores in woven and non-woven fabric, as I told that pores in the case of woven fabric is quite regular. Okay, this is a picture of a woven fabric and this is a picture of a non-woven fabric, and the people conceive the pore size like this: closed pore, blind pore, open pore. This is the way the people conceive. Actual pore is not like this. Okay, because this is a multiple type. Pores will be multiple type and they are all interconnected pores. If you see the non-woven pores, they are not very regular pores, non-woven pores, whereas the woven pores could be regular. Now next to it, if you see, if you compare the pores of woven fabric and non-woven fabric, non-woven fabric pores will be broader, pore size distribution will be broader, but woven fabric pores will be narrower. If you see, it is sharp. So woven fabric pores will be narrower, okay, within a range, and the non-woven fabric pores will be very wider, because that also have some practical implication. For example, if you want to remove all 5 micron particle, so pores in the case of woven fabric, you can exactly remove 5 micron and above. But in non-woven, because the pore size will be large, small as well, so you cannot ensure that. That's why nominal rating is possible in the case of non-woven, whereas absolute rating is possible in the case of woven, because woven you can guarantee that 5 micron and above you can remove, because that's why you can make the pores in that particular fashion. Now you can see this is a woven structure, and if you see the dimension of this square, if this is the diameter, 1 by n1 will be the distance between one thread to the another thread, okay, distance from one place to another thread. What is N1? Because textile person is, are more acquainted with this. Number of warp and weft yarn per millimeter. Basically, you are getting this size. Now, this size, okay, this dimension A0 and other dimension will be B0. If you take the root of it, you will get the equivalent port diameter. This is one of the way to estimate the port diameter. Whosoever in textile, they understand it, because basically it is the square geometry. You can also look it through microscope to get the idea about the pore size. Now you can also use the harmonic mean instead of that geometric mean, and you can also take the area. Suppose if you are using image analyzer, you can take the area into account, and from the area you can find out the equivalent size of the pores. So there is a different way to estimate the equivalent size. Sometimes it could be harmonic mean, sometimes geometric mean, and area can be estimated through image analysis technique, and from that also equivalent you can find out D. But one point we must remember, whenever the structure is relatively open, in that case only you can use this. Otherwise, for closely constructed fabric, there will be overriding of the threads. Whenever I talk about the denim cloth, for example, okay, it is not that all the threads are lying in a single plane. The overriding of the threads are taking place. So if there is overriding of the threads, you cannot make use of this equation. So that is the one of the caution. So for jammed fabric construction, and if because of the compressibility also, you cannot make use of that. Now pore size determination usually conducted by the following method of sieving method. So that is used for geotextile. Why we go for sieving technique for geotextile? Because the soil size will be much larger, soil particle size will be much larger, that is under consideration. So therefore sieving is very it is used in civil engineering application. Optical technique can be used, image analysis technique can be used, mercury intrusion technique. It is civil engineering, it is extensively used. Although the people are using the image intrusion technique in textile, but it is not at all valid because of number of reasons. Because you cut the sample in a small size and the mercury can intrude from on all sides. It is not that because the flow direction is the perpendicular to the plane of the fabric, you must have the pore concept of pore in the perpendicular direction of the fabric, not from all direction. But mercury intrusion method basically provide you the pore dimension when the mercury intrudes from all direction. That is number one problem. Another problem is that when the mercury intrude inside the pore, it get compressed. The material get compressed, so whole pore dimension will change. That is why the initial time, but it is extremely successful in the case of civil engineering application, because civil engineering it is very concrete. Okay, Start. So I think you are not from textile background. Probably you may have some difficulty. So media for liquid separation and selection of filtration system. So again there is a large number of slides. So if you see the ideal filter as follows. Whenever I talk about the ideal filter, remove all contaminants regardless of size. It could be fine, large. Okay, that is the ideal filter. Has no restriction. So that also gives us idea about the ideal filter. Has infinite dust loading capacity or last forever. Okay, that is not practically feasible. Is infinitely small, take no space. Okay, that's why certain times the vertical towers are being also used for filtration. Cost nothing. So, so this is the definition of ideal filter. Okay, which is not practically feasible. But we can target. So what we can do at most. So choice of filter fabric, if you see thermal chemical condition, because thermal condition could be different, chemical condition is different. It is not that only one material you can use for making the filter media. Different kind of media material can be used for making filter media. Now properties of contaminants including its particle size and concentration. Okay, properties including its size and concentration. That is also plays a vital role. The best separation technique for all types of contaminants are mechanical filtration, adsorption, coalescence, electrostatic effect otherwise. And if you see the same terminology again, it is valid over here. Filtration clarity, efficiency, filtration throughput, low cake moisture content, resistance to blinding, good cake release, resistance to abrasive forces. This is important for filter life. And for equipment consideration, resistance to stretch. Okay, resistance to stretch, because if there is a material get elongated, recovery may not be 100%. Resistance to flex fatigue, resistance to abrasive forces. So this is the equipment consideration. The filter size, hygienic process, the possibility of regeneration of the filter, and finally the cost. So in a one slide, you can see what are the requirement is there whenever we talk about the filter fabrics. Now in fact, whenever we try to go for any kind of research, we must look at the integrated science for filtration and separation. We'll have to start from molecules. Okay, for better filtration research is possible whenever you start from very beginning, and understanding should be clear starting from molecules. Okay, so it chemistry, it molecular, material structure, biology, everything we must understand. For example, why it is important? For example, if you talk about the pathogen, certain pathogens are very soft. Okay, so in filtration, they can pass through the pores. Okay, pathogen size may be larger, but again it can pass through the smaller pores because it can deform. Okay, so the biological aspect is also important. The surface characteristics is also important whenever I talk about that. Particle size, surface modification charges. The charges of the particle also matters a lot. Okay, what is the level of charge? What is the surface characteristics and particle size? That's why in COVID time the people are trying to use sodium chloride for the assessment of filtration performance. Okay, but the virus is work in a different manner. So I have attended one of the conference abroad one point of time. So they are using the bovine serum to characterize the filter media. Bovine serum, though that bovine serum is having equal characteristic, more or less equal characteristic to that of virus. Okay, so certain cases the people are also going for different kinds of testing system so that you can really characterize the material well, because virus testing is absolutely not possible. Certain bacteria testing is also not practically feasible. So whatever the safe bacteria, the people also try to test the material with the safe bacteria. Okay. So material consideration is also very important. Then the particle and fiber technology, fiber knowledge, fiber size, shape, particle velocity, droplets of particle versus fiber interaction. So single fiber theory is important, but as I told that in liquid filtration it is not much applicable, okay, because the role of fiber assembly is very important, because there could be direct penetration or seepage whenever the liquid viscosity is more. So particle can penetrate through the media based on the size of the pores. And then fiber filter structure. Next is the filter structure, how we are making the medium, that also plays a vital role. Okay, media play a vital role whenever we make the media, okay, because it is assembled of large number of fibers. So the media role is important. Now this is not also sufficient. If you go to the next one, manufacturing knowledge is also needed, okay, to design the filter media, okay, because it may be in a cottage form, in a pleated form. Whenever it is in a pleated form, again if you see, the flow may not be perpendicular to the plane of the fabrics. Flow will be at some angular direction. If you see the flow direction in the case of pleated media, so the how it is being made and what is the flow direction in the cottage, that also plays a vital role. We need to have the process knowledge, process control, system integration. We need to have the product knowledge also, because in the yesterday class it was also discussed about the regulation. Okay, regulation, safety standard, these are also very important along with the product knowledge. Product challenges, sustainability, and finally you will go to the market, value proposition, market size and unmet needs. So if you see, it is a lot of things are involved. So it is not the straight away you go for a experimental research and you come out with something. We will have to look into all the things before we can successfully go for a particular kind of research. Now designing of the filter media, just now I mentioned that filtration specific requirement is there. Specific requirement means efficiency based on the particles. So these are the filtration specific requirement. Application oriented requirement is also very important. Based on the application, the stress imposed to the material will be different. Okay, because different application offer different kind of challenges. And machine oriented requirement, I will see one by one. So if you see the machine oriented properties, rigidity is important, strength is important, resistance to creep or stretch. If the material gets stretched, obviously the tightness between the drum and the material will be poor. If it is not good, then filtration will be affected. Stability at the edges, resistance to abrasion, stability to vibration, dimensions of availability supplier, and ability to a fabricated sealing gasketing function. So in this case, if you see, abrasion is important, stage resistance is important, flex fatigue is important. These three properties are very, very important whenever we talk about the drum filters. Okay, because it will be continually abraded. If you see the knife, we are discharging the cake discharging possible. So knife will go for a continuously abrading the material. Stretch will be there, as there is a continually fabric will be under pressure. Stretch will be there, and flex fatigue, because it is a repeated phenomena. So that's why there could be flex fatigue. Application oriented property, that's whether it is having chemical stability, thermal stability, biological stability, because sometimes that biological material can act as a nucleus. Okay, in food industries it is very, very important. So that can clog the pores. Okay. So dynamic stability, absorbent characteristics, absorption, weightability. So these are the parameters which is important for application oriented property. And different fiber basically have some good feature. Okay, so we can have lot of choices to select the particular kind of fiber. So fiber selection is primarily based on application oriented property. Fiber, choice of fiber, because ultimately you are making the fabric based on the pore characteristics and whatever is required, but the choice of fiber primarily decided by the application oriented property. Okay. Now filtration specific property, if you look at smallest particle retained, okay, retention efficiency, resistance to flow, dart holding capacity, tendency to blind, already I have discussed this parameter. This comes under the filtration specific property. So three major aspects, one is the machine aspect, one is the application aspect, and third is the filtration specific properties. These are the major aspects whenever we are trying to select the media. And along with that, pre-coat also play a vital role. If you see here, this is the pre-coat, okay, and as I discussed in my last class, the pre-coat can help a lot for finer particulate collection because it can have a coating, okay, before we are going for actual material fade into the system, so it can give you the better filtration. So pre-coating is not possible in all cases, but in the case of press filter press, we can go for this leaf filter, we can go for pre-coating. It is not that in all cases we cannot go for pre-coating. So this is the description about the pre-coating that already defined. So I am just skipping few slides because lot of slides are there, and cost of filter media also matter because certain cases the cost is low. Suppose that is why a number of cases if you see oil filter are also being made out of paper. Although the fabric performance will be better, but sometimes if you see the oil filter, this is made out of paper. Okay, but it is also resin treatment because cost is one of the again important aspect whenever we are looking at the particular kind of filter. If you see there is a continuous process, also there could be discontinuous process, and some process like belt filter press in discontinuous process are very popular among all this. So this thing already to certain extent I have discussed. If you see the vacuum filter, okay, by means of vacuum also we can filter out the material because from the picture it is clear. So the drum filter also operate on vacuum filtration. The diagram is shown over here. Okay, suction is active in a particular zone, but after this zone, during the discharging the solid product, the vacuum is not effective in this zone. Okay, as the vacuum is not effective in a particular zone, so discharging will be easier. So this is the rotary drum filter and this is the application and key advantage of drum filter. So you can go through this because this material will be with you. So in different industries we can have rotary drum filter and their application has been highlighted. Horizontal bed filter, it is again the drum filter similar to that, but the filter media is in a horizontal. Okay, now the feed concentration, particle size and feed concentration is different. Okay, and this is the horizontal drum filter. About the disc filter, in yesterday video I have shown you about the working of a disc filter. Okay, so I am not going through this. Again, this is the horizontal pan filter. Again, this is in the principle of vacuum filtration. Okay, now this is the leaf filter. We will see that it is also the vacuum filtration. You can see how leaf filter is available in both the form. It is possible in the vacuum, also the pressure form. Both the form it is possible. So it can be used in edible oil, beverage industries. So it is basically outside to inside filtration. See, this is going to the outer side. And this is, you are taking out the oil, for example edible oil, by means of suction. So outer surface are being cleaned by vibration. But the leaf filter is also available under pressure mode. Both the form is available. Under pressure mode also the leaf filter is available. Now this is the another category. The first category was by means of vacuum, and pressure filtration is where the sludge content is more. Okay, particle concentration is more. In that case, we can go for filter presses. Filter presses is very common in many industries. Filter press, pressure leaf filter. As I told you that pressure leaf filter is also possible. Earlier one was the vacuum filter. Tower press filter. So picture I've shown you the video. Candle filter, dual belt field presses, vertical belt presses. So vertically also we are trying to organize. So that space limitation is there. Okay, that is one of the reasons that why you are putting it vertically. So this is a very common, very simple. Here if you see inside that chamber you are having fabric. Okay. Now this is the first process. You are basically feeding the slurry in the chamber. Okay. Putting high pressure to the slurry in the chamber. Now inside the chamber, continuously if you apply the pressure, then what will happen? The water will move out. Water will move out through the fabric and it will be passing through the channel and through filtrate it will come out. So basically we are applying high level of pressure to the slurry. Okay, as we are applying high level of pressure, automatically the filtration will take place because the water will squeeze out. Water will squeeze out and it will flow through the channel and it will come out as the form of filtrate. So this is the first step. Slurry feeding is the first step. Cake forming is the second step. Okay, third step is that cake form. So no more slurry feeding is possible. Even if you apply high pressure, no more slurry feeding is possible. So the next step is that you can separate the plate. If you separate the plate, then obviously the dry cake will fall off. Okay, so this is a batch process. If you see the drum filter I talked about, that was a continuous process, but this one is a batch process. Okay, so slurry feeding followed by cake, dry cake, and then the dry cake will fall off. Now this is the tower press. This is again a discontinuous process. So picture, I mean the video also I had shown you in my last class. Pressure filtration. This is the vertical belt presses. Dual belt presses. So inside the belt the material will be squeezed. Okay, I will showing the video also. You can see there are dual belt presses, how it works. Basically you are having this belt and another belt is there. This is the sludge you are moving and it is trapped in between the two belt, and this belt is basically made out of textile material. You see there is a belt at the bottom and also at the top you are having belt, and by means of belt you are squeezing the material because belt basically porous belt. If you are squeezing the material and taking the sludge in between, obviously the water will move out. Okay, so this is candle filter pressure filtration. You can see that how the pressure filtration operates in candle filters. So it can be used in pharmaceuticals. So it is outside to inside filtration. You apply high pressure. So through the candle, the clean water will come out. This is another configuration, perforated basket centrifuge. Centrifugal filtration, in the last class I have shown you the video. You can see the working of the pillar centrifuge also. This is the membrane filters, and different membrane filters is having different capability. Pore size range will be for reverse osmosis, it will be very low, 0.0001 micron. Okay, microfiltration it will be 0.1 to 10 micron. But the task is different for different types of membrane filtration. Okay, use of membrane filtration for water treatment, food industry, pharmaceuticals, industrial applications and other applications. Now the same thing again I am repeating, like selection of filter system, gravity filter. If the sludge content is very high, if the sludge content is less, in that case we can go for gravity filter, then vacuum filtration, then gas pressure system, centrifugal, and the mechanical pressurization system can deal with the large dirt concentration. Solid concentration is more, in that case mechanical pressurization can work. So the similar slide. Now this properties of the solid is important, properties of the liquid, operating parameters, configuration of filter media, principle of filtration. So that will basically influence the filtration efficiency. You can say lot of parameters can have influence on the filtration efficiency. So understand the liquid and particles, determining the filtration needs, appropriateness of housing, consideration maintenance cost, regularity compliances. Now selection of filtration system, I will not go through this because it will take time, because lot of slides are there. So here it is basically just to select which kind of filter to be chosen for a particular kind of application. Now going to the different kinds of filter, back filter. Okay, back filter will be similar to the net type of filters. Okay, it is not like the bag filter which is used for air filtration application. Air filtration application bag will be different. Here this kind of bag will be different. Net like of construction is there, and many industries, food beverage industry, paint industry, this kind of filter is used. This is the cartridge filter. I had shown you the cartridge filter. This is the pleated cartridge. This is another pleated cartridge. Application will be different. Okay, see the kind of pleating. This is a relatively new design. So pleating will be in a different configuration. This is engine oil filters. You can see, okay, I don't know why it is not working. This is the hydraulic oil filter.
Lights of the Donaldson spin-on liquid filter, which is made for durability and consistent quality. The Donaldson louvered center tube and spiral lock seam allow.
Why that hydraulic filtration is required? For operation of crane, it is required. Okay, for heavy vehicle operation of the crane, it is required. If the contaminants are removed, then obviously you will get higher wear and tear. One thing I must refer.
The Donaldson product lineup includes quality hydraulic filter assemblies, filter heads, replacement spin-on filters and filter cartridges, test points, and reservoir accessories. Let's look into the hydraulic oil holding tank. It's here that most of the contaminant finds its way into the oil. First, it's important to note that new hydraulic oil is not pure. At an approximate ISO cleanliness level of 2119, it is significantly higher, that is less clean, than OEM standards. This has prompted a leading global heavy equipment manufacturer to recommend filtering new oil before pouring it into the hydraulic tank. Water can also enter the hydraulic system via the holding tank when moist air inside the tank condenses as the outside air cools.
So it is possible in offline mode also.
Products for hydraulic systems of various applications and sizes. Looking at this animated hydraulic circuit, note how the oil is drawn through a strainer in the tank, which removes larger debris. The oil then goes onward into the low-pressure pump-protecting suction filter. Low-pressure filters are the most commonly used type in a hydraulic circuit. Donaldson has a broad product line of low-pressure spin-on, cartridge style, and in-tank filters for solving filtration challenges in virtually any application. From here, the oil, which has been filtered of potentially damaging particulate matter, goes through the inline pump. It is then filtered again in the high-pressure section of the circuit. This second filtration is to protect the expensive hydraulic components, the muscles of the system, from particulate and debris. All of our high-pressure filters contain Donaldson Syntex synthetic filter media, specially developed by Donaldson for high-efficiency liquid filtration. After doing its work, the hydraulic oil proceeds back to the holding tank. It first passes through the medium pressure return line filter, which removes contaminants generated during component activity. Ideal for medium pressure application in the circuit is the Donaldson Duramax series. Duramax is well known as the highest rated spin-on style filter available and is most often used in return line positions. This new Duramax filter allows you to choose between a spin-on or bowl cartridge style filter without changing heads. The new filter interface makes service easier and provides reliable sealing without having to torque to specification. Its improved performance is a necessity in some applications for meeting ever-increasing system cleanliness requirements. Although cellulose media will suit some applications, others may require Syntex synthetic media in medium pressure applications. For the same media area, the Syntec media gives a lower pressure drop than the cellulose media due to thinner fibers.
Okay. Now this is for better working of the crane. Okay. See, one point I must mention that whenever we talk about the fine particulate coarse particle can cause more damage to the crane. It is not that finer particulate matter. Whenever you are breathing, fine particulate matters a lot. Okay, it can go deeper to the alveoli. But whenever you talk about the machine, engine oil, then the coarse particle matters a lot. It is not fine particle, it is the coarse particle that can cause more damage to the material, to the injector engine, okay, in the injector nozzle and also in the hydraulic crane. So these are the different type of cuttage, nominal rated cuttage. Why it is nominal? Because it is absolute not possible. It is yarn is wound onto the package. Okay, high flow filter cuttage, different types of cuttage are there. Okay, coalescing system, these are the coalescer. Yes, here some of the definition I had given. Here if you see if you want to remove the large micron rated cartridge, then lesser pressure drop. If you are going for smaller micron rated cartridge, greater pressure drop. So that also I have explained already. Okay, another aspect is that absolute versus nominal rating. Nominal rated cartridge means 60 to 98% removal of a particular size. That is known as nominally rated. Whenever I say absolute rated, that means it will be 99.99% removal. Absolute rating is possible in the case of woven fabric, as I told, and whereas non-woven fabric can be used for nominal rated cartridge. Okay, and another aspect, if you see, one is that standard versus pleated. Pleated can give you more larger surface area, but the flow direction will be different. Okay, flow direction will be different in the case of pleated one. Another important aspect is the gradient density filter. If you see number of cases, this is the new development that gradually the pore size becomes smaller and smaller. Instead of making a uniform structure of pore size, it is better to have larger pores initially, because that will give you the energetically more favorable condition and greater particulate capture. Fine particle will be captured at certain depth. So the pore size is not uniform throughout the body of the filter media. So this is known as gradient structure, density filter, that also are being used extensively.
Filter, like it would be more of a composite. Now, within one
Yes.
particular, we cannot have.
Yes, it is a kind of composite. Sometimes what the people do.
Blinding, then others will also get affected. Blockage will occur if it appears in the bottommost layer. Then the top.
See, this will operate in the depth filtration case only. In surface filtration, we cannot go for gradient density filter. Whenever we are making a cartridge, basic idea here is that energetically it is more favorable, because you are separating the large matter first, then finer to finer material. People also think about why not use the nano layer at the bottom, nano layer. Okay, in the cassette, but if you are using 100% nano layer, one is the cost will go up, but pressure will also very high. So only a nano layer at the bottom. okay, coarse layer on the top. Okay, so the gradient ratio can be of, this is the use in number of places for better filtration. Now basic consideration, this also I have highlighted. So, and this temperature, based on the temperature, chemical nature of the fluid, we can choose the right kind of material. Okay, this is the few properties of the fiber. Yes, coming to this whole case, configuration of filter media from textile material. One is the membrane that I have already discussed. So in a systematic way I have mentioned it here. Another one is the yarn. Yarn also take as a filter media, because whenever you are making it a cottage, the yarn can also lead to filtration. Woven or knitted fabric, that is another aspect. Non-woven fabric, primarily needle punch, spun bond, spunless are used. Other category like sling fabric, duplex, semi-duplex, these are also being used. Now you can see, other than textile, you can have the metallic filter also. So several types of metallic filter you can see, metallic or non-metal, metallic and ceramic filter, paper filter, sintered metal powder or fiber, plastic, metal filter. So this side it is metal screen, okay, metallic filter cartridge, oven filter mesh, wire mesh, porous plastic tubes. So apart from textile also you can use the other material also, non-textile. Sintered metal powder or fiber. So in this case, sintered metal powder, you can, this also is having the filtration capability. How the sintered metal fiber has been made? Any idea? This is the metallic fiber in non-wovens. How it is made? Basically the powder is dispersed on say polyester. Polyester is melted afterwards. So that whatever is the dispersed powder, they will take up the form of fiber. So first of all, you will have to make the non-woven sheet made out of polyester. You can disperse the powder. Okay, so it will be having some coating on the fiber. After that, you can melt that fiber. If you melt that fiber, it can take up the form of fiber. Okay, so the basic idea here is that it can give you the lower pressure differential.
It also lead to something like the hollow fiber.
No,
Because
no.
once you melt the fiber, then
Melting, see, ultimately if it is used for hot, when the temperature is high, okay, when the temperature is high, we can go for sintered metal fiber or powder. Okay, ceramic is also having very large capability. Instead of ceramic metal, we can go for ceramic when the temperature level is suppose more than 1000 degrees centigrade.
Emulsion spring system. That is spring system.
So certain cases catalytic recovery, then we may have to go for very high temperature filtration.
Whether the fiber form will be in hollow form because the
No, fiber will come out. It is so fiber will come out in a polymer form, but it will be a kind of porous type of structure. It will take up some form of the fiber because of this sintered metal. But advantage over this is that it will give you the better capability for the fluid flow. Okay, powder form the fluid flow resistance will be more. In fiber form the fluid flow resistance will be less.
in case of the sintering of metal, we are using polymer as well as a metal.
No, polymer, only powder. We are not using any polymer here. Here in this case we are using polymer. In this case it is 100% powder. Yeah.
In case of the sintered metal fibers, we are using a one polymer, another is the powder.
Yes.
From that we are manufacturing the fiber.
Yes.
This kind of a emulsion spinning system. I think. In case of the
Maybe
ceramic, they are
I don't
using
know
emulsion
exactly, but this is the how it is being made. If you see, this is the other type of various configuration membrane filters that I have discussed, and we can also have the symmetric membrane, asymmetric membrane. Okay, symmetric membrane will be simple, but asymmetric will be high performance membrane. And nowadays, basically, people are going for asymmetric membrane. Let us look at the asymmetric membrane. One of the asymmetric membrane which is used in RO, polyamide layer 0.2 micron, polysulfone layer, the pore size could be 0.0001 micron. This is the pore size in polysulfone layer, and polyester base is only for support. Basically, you are having three material into one system. Three material into one system. It is an integrated material, three material in one system. And this is very much porous. Polyester base is very much porous. Okay. Here polysulfone layer pore size will be 0.0001 micron, and the polyamide layer is the upper layer, which is having 0.2 micron. So this is basically asymmetric membrane. Okay, because earlier time the people trying to use the symmetric membrane. So only you are having one polymer. Now we are going for multiple type of polymers.
Gradient density.
Yes, kind of gradient density. Okay, but that can give you better performance. Asymmetric can give you the better performance as compared to the normal one. So this already I have discussed. Okay, one thing I like to mention that basically I will also cover the testing part to certain extent. Testing, characterization and evaluation. What do you understand by evaluation? Any idea? What do you mean by testing? Testing means we can simply test the material. Characterization means we are characterizing the material based on the test result. So it will be high performing material or whatever. Whenever we perform test characterization or testing, it is done in a small setup. Like yesterday you had shown in a very small setup to show that how the material can be characterized. How the material can be tested, testing, and followed by we can say that this material flow behavior will be better as compared to other material. But what is evaluation? Any idea? Because people are using it loosely without having any idea. They are using this, sometimes they use evaluation, sometimes they use characterization without proper understanding. What do you mean by evaluation?
Assessing the property.
Assessing the
Actual assessing the real performance of the material, field performance, and that is one of the most difficult tasks. Translate lab data into application level performance and decision making. That is basically evaluation. So field test, I mean the testing in the lab can give you the different kind of result, but whenever you are going for application, if you see the flow dynamics, it is very different. In different machine, the flow dynamics is very different. Application, how it will perform, that is a big challenge. Because lab scale also seen that okay, its life will be less or higher. That is in lab scale I am saying. Suppose in lab scale we can say that it is maybe having 2 times longer life than this, but in application wise what will happen? That is the one of the most challenging tasks. Again, in Bloom taxonomy used to say creativity, evaluation, it comes at the top level. But in this context, evaluation means we must be able to assess the material performance we will use. For example, if you are going for abrasion, abrasion is basically an accelerated testing. Whenever we do the performance testing in the lab, it is basically can characterize the material. From that, can I say that material is having double abrasion resistance? In real life, that will give you the double durability than that other material. That is the main challenge. Evaluation is the main challenge. Okay. For example, the yarn strength is less. Can I say that it will perform inferior in the while it is in the machine? We cannot say like this. We cannot say straight away. So there are a lot of aspects. There are a lot of aspects before we are going for evaluation, and there that is the thing is lacking in most of the research. In the most of the research is restricted to testing and characterization. It is not translated to the industrial practices. Why it is not translated? Because we are lacking in the evaluation part. In future, what I say that we can have AI technology, and if you feed the many data in AI system, how the material performs, that could help us a lot for the evaluation of the material. We can feed the raw data and we can also see what actual performance data in the industry, and from that we can get a lot of information. In fact, because in multiple forum I have also addressed this issue, evaluation issue, although it is not understood properly, I mean about the evaluation of the material. Now this is the practical requirement. I will try to finish it off within 10-15 minutes. I try to. So pore size, rating, efficiency, and all these are important. So this already I have defined, number based and mass based. We will look at it, the practical implication of this. Whenever I say that total suspended particle in slag minus total suspended in sample, it is in the form of gram. Okay, weight. Okay, and beta, if you see, it is in terms of number. So here in this term of mass, and other places it is terms of in number. Which one is important and why? It is not the why is very important for any academic research. Why it is so? Should I use number? Should I use the mass? So you have to see the application. Because in the beginning also I was discussing about the cleaning of wafer in semiconductor industry. So the water should be 100% pure, because the particle in the water that could be bigger of 5 micron, 5 nanoscale, because 5 nanoscale could be the feature of a semiconductor. So it could be bigger than that size. So the point here is that here it is emphasizing on quantity of the particles, not on the mass. So mass is one hand and particles is one hand. So suppose from this picture it will be clear, although I have discussed this issue in my earlier class. Suppose in downstream you are having one particle. Upstream is same in both the cases. Filter media, upstream is same. So here I am talking about 1-2 micron particle. In this side you are having 1 million of 0.02 micron particle. So suppose if you see mass of 2 micron particle divided by mass of 0.02 micron particle, what will be the ratio? 1 million. Okay, because this will be the volume. From volume you can take the density into account. You will be able to find out, because density will be the same for both the cases. So density will get cancelled out. Okay, so if you take the volume, if you take the volume, and from the volume you can derive the mass. In both the cases, what will be the mass basis efficiency? Anyone? What is the efficiency? Whether there will be any difference in efficiency on the basis of mass? Again I am repeating, here you are having one particle of 2 micron. Here in this case mass of 1 million particle is there, which are of 0.02 micron. Mass of 1 million, particle of 0.02 micron. Whether the efficiency will remain same or different? Yes, mass base it will be the same, because 1 million of 0.02 micron mass are same to that of this. But in practical life, then in number of application, number plays a vital role. If you see the air filtration application, nano particle can give us more damaging to the human health as compared to only 2 micron particle, because it will be immediately arrested by in the tract, in the respiratory tract it will be immediately arrested. But fine particle can go deeper into the alveoli and it can cause more damage. Similarly is applicable to the liquid also. So application wise we'll have to see whether to be used number or whether to be used mass. Okay, because there could be great impact of this very small particle in real life.
For the mass applications, which one is the appropriate number?
See, if you are going for sludge, removal of sludge, high concentration, you cannot count the number. Sometimes what the people do, they only count the number on downstream side. That's all. Only downstream side. But they cannot compare or find out the efficiency. Only mass base they are trying to find out. And number also they count. So that was there in the people also in some of the developed countries, they are also started thinking, why PM 2.5? You know the PM 2.5 indicator is all based on the mass. That is the unfortunate part. But with the same mass, if you are having 0.001 micron particle, that will be very much damaging for human health. Mass may be the same, but that could be more damaging. So therefore some countries have taken initiative. I don't know whether it is in the part of the process or not, but at least not in India, but in many countries people have thought of this aspect. So this aspect is very important aspect. Cake discharge, mass of cake discharge, total mass of the cake form. This is the cake property. This can be done in the lab scale research. Moisture content, dewatering efficiency. If anyone is doing the lab based research, they can find out in a small setup, they can find out dewatering efficiency, moisture content, okay, blinding tendency, weight of fabric after filtration. This is temporary blinding, initial weight of the fabric. And permanent blinding means what? After washing cycle, you can see weight of the fabric and initial weight of the fabric. Then that can give you the permanent blinding, because after washing whatever remained, that means that is a permanent blinding state. So you can find out the permanent blinding also. So it could be based on the weight, it could be based on the solid. You can have similar equation for solid as well as this one. Now coming to that, if you see the different yarns are being used, staple yarn can give you the maximum clarity because it is having hair inside it and it is porous structure, and multifilament can give you the monofilament can give you the least clarity. Maximum throughput is possible monofilament, least throughput is possible in staple. Okay, low cake moisture content is possible in monofilament. So what is in the slide, some of the properties is good for certain thing, okay, certain filament or yarn, certain properties are good for other cases. That's why I discussed about this material. Face side is multifilament and back side is made out of spun. Because if the face side is made out of multifilament, okay, you will get the advantage of easy cake release, okay, but back side is made out of your spun yarn staple fiber, you will get the better abrasion resistance. So you will get the both the advantage by having this kind of structure, okay. So I am just skipping it, okay, different combination is there. Now you can have strategic research. I am not going through this because you can have some strategic research so that optimization is possible. These are the other kinds of material: double layer weave, satin weave. Satin weave, as I told, that it would be better to dispose of the cake. The surface will be smooth. So you can also have the metal fiber fabrics. You can see that different metal fiber. Okay, duplex, semi-duplex kind of material, link fabric. Link fabric is already I have shown you, and this is the comparison where the link fabric can be used duplex and semi-duplex. But obviously, whenever the contaminant size is large, in that case only we can employ the link fabric, duplex fabric, semi-duplex fabric. But if you see the link among them, the link fabric is more strong. Okay, reusable. Okay, so depending on the plus point, we can use the different negative point. We'll have to consider that. Now, non-woven fabrics. This is the classification of non-woven. Three majorly non-wovens are being used. Needle punch, because many of you are not from the background of textile, you may not get the things properly. But gradient density media can be made in the non-woven fabric also. Okay, if you see one layer is made out of different fiber, another layer is made out of different fiber. You can make the finer fiber layer at the top, you can have the coarser fiber at the bottom, but it could be otherwise also. For depth filtration, finer fiber layer should be at the bottom, coarse layer should be at the top. Okay, now nanofiber uses, what is the basic concept why the nanofiber gives us the larger filtration capability? Anyone? Larger surface area. That is the primary reason that why that, because there could be better interaction between the particles and the fiber. If you see, compare the surface area, it could be large many more times as compared to the normal fiber. So it is not the pore size and something else. Okay. Usually what happens, if you consolidate the material, you can get greater larger surface area. Okay. Compact pore size is also reduced, but pore size is basically have the resultant, but one should not connect the pore size directly to the efficiency. As I told already that for if the contaminant level is very low, in that case only you can connect the pore size to the fabric, to the filtration capability. Now this is the finishing treatment that can also improve the filtration capability. Now future development, if you say that all the time we are going for filtration efficiency, flow resistance, filter life, storage, so this I have written in a one place, okay, because the research are continuously going for improving these aspects. Now if you see, this is the some of the advanced area of research, nanomaterial research, bio-inspired filtration. For example, if you are going to develop the filter material similar to the lotus leaf, okay, so hydrophobic material, oil can pass through it, but oil cannot, but air, the water cannot move through. If you see the lotus leaf, because of the air entrapped into the pillar, nano pillar, the water roll out. So if you are having oil and water mixture, oil will be able to pass through, but water cannot pass through. If you see the plant, root of the plant also takes up the water, but it doesn't take up the toxic matter. So many things is basically inspired by the what is happening in a biological field, mimicking natural system. Okay, we can also have the smart filter, smart system, which can regulate the pore size. Okay, energy sector, medical sector, and these are the emerging area like microplastic, because microplastic, if you burn the plastic, there is a problem because dioxin is generated, that is harmful for human, because cancer, it can lead to cancer. If it is in the water, that also lead to a problem. So both cases, it is having a great risk to the human. Okay, that's why many countries it is banned. You cannot throw the plastic here and there. Okay, many in the India also many places it is banned. In Kerala, if you go, you see the plastic is banned. Okay, in Manipur and some of the northeast area, Himachal also, it is not being used because this it can have lot of impact on human. So removal of microplastic is also important. Okay. Now here I have defined one term. If you see forward osmosis. Now you all understand osmosis. Let us look at what is osmosis, by the way. I don't know why it is not working. Can it work? No, I don't know why it is not active. Huh?
Maybe that is not in the directory.
No. Okay, what do you mean by reverse osmosis? Any idea? Why it is called reverse?
Passing of material from higher concentration to lower concentration through the semi-permeable.
Now suppose in one side you are having water only, another side you are having contaminant water. So basically from which side to which side the water will flow?
Low to higher.
Lower to lower side means what side is lower? Pure water is lower. Lower concentration. Lower concentration to higher concentration. So if you apply pressure, then what will happen? Reverse. Now forward osmosis means what? You are deliberately in the pure water, in place of pure water, you are keeping a water which is having higher solute. Okay, so normal process you will have to apply high pressure, you don't have to apply pressure over here. Normal process it can be performed.
Simplest example is kismis. Kismis.
Huh.
Whenever we are putting in the water, the swelling of kismis, that is the reverse osmosis. Kismis represents the example of reverse osmosis.
So some of the recent development, DRDO developed multi-layer nanoporous polymeric membrane for high pressure seawater desalination. So these are the some of the information I am providing. For removal of microplastic also, sponge made out of cotton and chitin can remove 99.9% microplastics. Okay, nano composite membrane are also developed. Thin film composites are also being developed. Forward osmosis process. So disposable, recyclability are also becoming important. Sustainability is very much important with the time. Green impact in production, minimal environmental impact, and energy saving. This is all from my side. Probably I have taken 10-15 minutes more. Okay, so any question? Because you can get lot of idea from the slide that will be shared. Also one of the book will be shared with you. I don't know whether it is shared already or not. Whether it was shared, so probably by today it will be shared. Okay, so you can go through this, then you can have idea.
So industrial RO and bag washing and how things are doing their performing.
Industrial?
In industrial RO system, bag washing or cleaning is doing regularly, as you already shown in the
Now, industrial wastewater, actually, as I told, that it is a multiple stage process. Initially, by coagulation and your flocculation technique, you can remove that all sort of heavier particles, large particles. Then at the you can also go through the filter press to remove that cakes. Okay. Then finally, you have to go for this. So suppose if it is used for the drinking purpose or whatever will be the purpose, based on that you will have to select the stage. Okay, otherwise I have seen a number of places the people are going for filter press, okay, to consolidate the cake, and cake is disposed of, okay, in landfill area. So it is basically you will have to one has to go for multiple steps of process. It is not a single step.
So my question is regarding an RO backwashing.
Backwashing.
RO.
Huh.
That is usually performed in industry.
I think they usually perform. I don't know. I don't have the idea. Probably they should perform, because if you want to get a longer life, okay, obviously you will have to go for backwashing.
I have visited trident industry. Actually, they are using RO and they are using clean water for the white towel dyeing process. Actually, in that case, they are changing the cartridge. They are not using backwashing, especially in the RO.
That only people use reusable use and throw cartridge filters because it's cost effective.
Yeah. Yeah, yeah, post. No, backwashing they are not using. I have not seen. In RO, they are not using backwashing.
So we have taken a 5 minute of break. So if you need to
CPP plant, they are not
go
using
and
RO.
washroom or drink some
Yes.
water, we will
Probably you have to change PhD in front of my name, Professor. That might be better. Yeah, K.J. Choi. Professor K.J. Choi. Well, can I start?
Yes, sir. We are waiting for you.
Everybody here? I believe this one, which is the designing filter media, that's actually my area of expertise. So the introduction part, Professor Mukherjee, he already covered the introduction part. So I'm going to cover detail of the multi-layer construction, how you can do it. That's the key portion of it. To me, this is really important one. You know, what is pattern? Pattern means protecting technology. That's one. What about the other? The other is uniqueness. which means no one has it. Yeah. However, once it's patent, then you have to have license to use it. But you do have license already, because I'm giving you the permission, along with the department, textile department, anything working for textile department, I can give you the license, so you can use. The equation that I have is really, really applicable to the round membrane. Huh? Yeah, because they use the same kind of membrane and several layers of it, right? So you can actually calculate absolute the rating using that equation that I'm going to give you. Actually, it's right here. It's right there. Yeah, right there. Yeah. So to me, the right now, I think I'm the only one who has the theoretical background how to design the multi-layer, the high efficient filter media. So that is my core subject for today. But beforehand, somehow we have to go over some basic information first, so that you can understand better. The introduction part, I believe the Professor Mukhopadhyay, he already covered basics of it, like define the filtration objective and purpose and type of solid liquid. You have to know, determine the key filtration parameter. He already covered those. Then select filter media type. He also covered this one. I believe he did cover this one as well, right? And property, pore size rating, thickness, performance evaluation. But 7 is quite important, the compliance and standard. Probably that one I may cover really briefly last day, testing and evaluation section. So it's repeating the microfiltration 0.1 to 10, ultrafiltration, and then the application here. ePTFE, to me, this is a future direction, even though they call it PPAR. However, ePTFE doesn't have any water see, there is no dissolve in the water, any portion of it. If some portion of dissolve in the water, then you have trouble. But currently, the issue is ePTFE. PTFE is forever chemical. There is no way we can landfill because it's not biodegradable. That is issue. However, PTFE, we are not using a lot, really small amount, probably screen that we use to support PTFE might be a little bit issue, but to me, the EPTFE is future directional membrane. You know why? The fiber size is quite small. Second, fiber itself is quite strong, really strong. Third, manufacturing process is a lot easier than normal the membrane process. The other, uniformity. That is a big issue for me. So to me, the EPTFE gonna replace all the current membrane will be replaced by the EPTFE. That's my view. So the EPTFE, without EPTFE, medical field, they have a bunch of trouble. They are using a lot. Right? Even when they do the tooth planting, implant, and then they do use a lot of the PTFE, EPTFE, too. That's one area. Also, a lot of the inside when somebody operates then they do use a lot of PTFE as well. So PTFE, without PTFE, medical field, they have a bunch of troubles. Huh?
What's the difference between EPTFE and PTFE?
EPTFE expanded. I'll show you later on. I'll show you. So water treatment, currently they do use food, beverage, chemical processing, medical devices. Wait a little bit. Here. This is stretched PTFE. You have to extrude the PTFE and then make sheets. And then they have to stretch machine direction, and then they have to stretch the transfer direction. We normally call it tenter, T-E-N-T-E-R, tenter machine. Then you can stretch so-called biaxially, simultaneously stretch. I don't know whether you notice that. This is a 30 micron bar. How small fiber is. Also, look at this, the uniformity wise. To me, currently, however, this one, I did it myself. In fact, I associate several companies, currently 3 companies. So they already have the PTFE stretching line. They're already producing the sellable EPTFE. One in Japan. Actually.
Company names?
What?
Company names?
No. No. I'm not supposed to. Yes. So I do have some patents on PTFE too, stretching patent. Well, that's why I'm still working, traveling and working. So I don't know whether you notice or not. This is EPTFA. This is ultra high molecular weight, high density polyethylene. So they try to duplicate the EPTFA, but they are still doing it, but it's not really possible. I don't know whether you notice or not. This is the best material so far. Yeah, compared with the EPTFA, still lots of issues. Yeah, there are a lot of void there, void. Even though it's 10 micron, almost same size, same size. No, same magnification. But still, the high density polyethylene, ultra high density polyethylene, is far, far below. So this is what I stretched. I actually spent about 3 months to produce something like this. But normally, this is what you see, like this. Fiber and some knots there. But still it's okay. If there are some knots, something like this, then the machine gonna be a lot cheaper. But if you like to do a lot of fibers in it without knots, then machine cost is a little bit higher. This is the ultra high molecular weight, the high density polyethylene, stretched. They compare with EPTFA. E means expanded. Yes. In fact, this one is currently commercially available for liquid filtration. Now, well, you already noticed that the round, the cartridge, several layers of it, right? It's not single layer, but same membrane, but it's several layers, not single layer. Then how actually you can calculate out the better the absolute rating?
What is this slip flow effect?
Oh.
Slip flow effect in the first line examination.
Less pressure drop due to slip flow. I'm sorry. Less pressure. ER should go off there, not this.
What is slip flow?
Huh?
Slip flow.
Oh, this is kind of the academic jargon. The slip flow is going over the fiber. Normally, if the flow touch with the fiber, it stops there. But fibers are really tiny, it actually slips go over. It's not stopped. That's actually the kind of theory, then pressure drop quite low because it stops there instead of slipping over. So that one, if I want to explain it, I need to put in some equations. So it's a little bit complicated. So the important thing is a tailored pore size. So liquid filtration, pore size distribution. Oh,
So if fluid will flow, fluid will slip over the fibers, then filtration efficiency also reduces.
here, I'm not talking about filtration efficiency. I'm only talking about pore size. Pore size. See, liquid filtration, the pore size is key. The air filtration is different. Air filtration, fiber size is important. Yeah. When liquid filtration, the pore size is key. So all the equation or designing equation, everything related to the pore size. We normally call it mean flow pore. So there is some distribution of pores. It's not single like that.
Actually, the nanofiber offers the larger surface area. Okay, so from that, if you see the larger surface area, resistance will be more. That is the general principle. Whenever I talk about the seed flow, that is for the gaseous molecules. Gaseous molecules are so small that it can flow fast. It is not giving in the resistance that way. Normally, the surface area applicability is up to a certain extent. But if you are going for nano range, that is not so much applicable over there. Are you getting my point? Normally, if you take the coarse fiber to relatively fine fiber, you are having larger surface area. Larger surface area will give you the higher resistance. Higher resistance means higher pressure difference. The nanofiber is having such kind of very fine, so that the gas molecules also can slip past, because the gas molecules also plays a vital role for pressure differential. So you cannot straight away equate like the larger surface area, because nanofiber surface area will be many scale higher. Okay, so but the permeability is not that extent lower. Are you getting my point? Permeability will not be in that scale lower, because the gas molecule will be able to flow fast. Because I am talking about gas molecule. Okay, not the particulate matter. Gas molecule will be flow fast. That's why it is not to that extent. Resistance obviously will increase, but it will not extend it will not extend to that extent, to that degree.
Well, he's correct. The basic theoretical approach around the fine particle, fine fibers and slip flow, that theory developed under air filtration area. However, the liquid filtration, viscosity is a lot higher, density is very high. So I believe it works a lot better in liquid filtration than air, I think. Yeah. Why epitaphy extended? Certainly, nanosite. Huh? So 38 nanometers up to 200. Actually, that I measured is a lot less than 30. Hydrophobic, excellent chemical, and superior cleanliness. He's talking about the dirt removing layer. You compare with the epitaphy, it's not really comparable, because epitaphy, once you put it on the surface, the whole thing is super wide. And
Because of nanopores.
The surface of the epitaphy cells. Here, I don't know whether you notice some sort of the wheels made of the epitaphy, something like that. And then there is no mamo. What do you call it? No, that is terminology. We sometimes measure that one. What about smoothness? Smoothness of the rubbing. What's your rubbing is yes, PTA fiber. Ah,
It's a very, very smooth fiber. We only have very low coefficient of friction.
yeah, your friction is friction coefficient is really low. There is terminology for that, but I could not remember. Anyway, that's a good one. Long service lab. Right there. Low coefficients of friction. Right there. Excellent dielectric. Low electrostatic charge. However, if you like to produce the EPTFA, this is not easy. You have to have some sort of cell-level product, but normally it takes 5 years, starting from the coming out of the cell-level product. Also, you need to have some hands-on the people as well. So it's not that easy. Now I'm going through how you design the multilayer media. So this is basically first layer is coarse layer, and going down tight layer, something like this. The other thing is, if you're gonna separate the layer, or if you're gonna adhere each other, bond each other quite, then the characteristic is a little bit different. Sometimes you use some sort of the support layer in between. So round cartridges, sometimes they do that way. Here, this is interesting one. That is coarse layer, looks like this. Blue one is fine layer. If you combine both of them without having any space, then you have this one. So, in fact, mean flow pore size is going to be a lot smaller size. If you have some space in between the layer, then this is what you see, like this, red one. So this one has part of this characteristic, that one has part of that characteristic. I believe you understood. Tightly bonded and loosely bonded, characteristically different. Yeah. Well, I don't know whether I'm going to go through some mathematics. Yes, Hagen-Poiseuille equation. Well, just like what somebody asked question on the first day. This is all bundle of capital, the assumption. Assumption, yeah. Now, from that, the coarse layer with the largest pore should be thicker than, why? See, yesterday, I actually modify everything, but somehow I couldn't find my file. But anyway, the thickness of next layer should decrease as pore size decrease in order to increase the life of filters. So the mean flow pore size and the air permeability of well-laminated multilayer media can be calculated with the property of individual layer. That's the key point. So, you know, the tortuous path, non-move on anything, is there is tortuous path. Then how we can assume the tortuous path, actual the distance of travel? This is really tough, but however, there is some assumption. If you know the porosity, then 1 over porosity is tortuosity. So let's say porosity 1 over 1, then tortuous is 1, then it's going through fast. So somehow you have to measure what? Porosity of your material. Do you know how to measure it? I have something there. Actually, I modified my presentation last night, this morning, so that you can have your own lab. Also, I insert several drawings. So you already seen, it's not yet perfect, but how it works, right? So from that, you can build your own lab if you have money. Anyway, I'll show you. So, if there is the double layer like this, then if it is when you look at it, then the pore, you can small pore, because it's, oops. Right here. This is porous measurement. You have to use the wetting solution. Cut 1 centimeter, 1 centimeter, and measure the thickness of sample. They calculate the volume and weight of the sample, and immersing into the wetting solution, and weigh it, and weight the solution and the volume of pore, and then you can actually calculate the porosity that way. So it's quite simple.
Sir, why we have chosen a fluorinated solution in this case? Why not water?
See, somehow I didn't give you some the way to measure the contact angle. The contact angle is quite important. If you use the water, then there are some probably a lot more error than wetting solution. Wetting solution means it wets all the surface of fiber. But water contact is quite large. It won't cover the surface of the fibers, which means you have some curvature like this. So there are a lot more error than wetting solution. You can use water if you want to. But however, when you handle it, you're going to lose a lot of water out of the media itself. It's not going to stay long enough. I hope you understand.
Another point is that water, you have to see whether the fiber swell in water. If there is a swelling, then obviously the porous structure will change. Okay, during the measurement, that also should be taken care of. So if you are taking with the help of polyester, it will not swell. If you are going for cotton fiber, it will swell. That void will change.
So this is what I do. Actually, not I do. My lab people, they are doing it this way. So you have to use the Laplace equation, and then you come up with this one. This equation is key equation. So make it simple, right there. The D is overall mean flow pore diameter, D. What about the lowercase d? This is mean flow pore diameter of ice layer of, well, individual layer of the mean flow pore. The other one is epsilon is porosity. So you have to measure each layer if the layer is different. If it is single layer, use the double layer, making double layer, triple layer. Then you don't have to. This is the double layer with the same membrane material. Then overall mean flow pore is 0.5 individual layer of the pore, mean flow pore divided by the square of porosity. What about the triple layer? Oops. A triple layer is something like that. Actually, this works. So then how you're going to make the tailored multilayer microfiltration media? Actually, this is not microfiltration media. The membrane media might be better. So you have to have target. Whether you're going to make 0.1 micron size or 0.001, and then choose first layer. Most likely, currently, they are using same layer. Anyway, so this is the actual result. Single layer pore size distribution like this, and then porosity is 97%. Then if you do the double layer, then like that, it's about 2. Once you use the equation up there, it looks like that. So when you look at it, it's really close to the actual layer. This is the triple layer. The porosity is a little bit lower. However, if you use the same equation, you can predict almost saying 1 micrometer. So that's the design of multilayer media. The detail is here. Also, I gave you 2 other my old the articles. Yeah, articles. If you combine those 2, then you could understand this one a little bit better. So from now on, viscosity issue. The liquid filtration, one of the important property you have to know is viscosity. So this viscosity is somehow the function of temperature. So then we heard about a lot of the viscosity. Also, you can buy some equipment to get some viscosity value. However, this is what I really want you to do it. That is, yesterday I gave you some equations what to do. Yeah. Yeah. So this is the dynamic viscosity measurement. And then the principle here is capillary rheometer principle. So my graduate, master, and PhD dissertation, I use a lot of the capillary rheometer or some other rheometer. So we call it the rheology. The blood rheology is currently really popular. Polymer melt rheology or polymer solution rheology is quite important too. So if the liquid filtration, some of you want to know the viscosity of it, then this is really quick also, because once you measure the viscosity, that's not really shear viscosity. So if you really like to know, it's not really static viscosity. You want to know shear viscosity. This is how you're going to do it. Here. This is diameter of capillary. This is the length. We used this equation yesterday in order to get the shear viscosity. So shear stress normally eta, but if it is the so-called power law, then sometimes K, but it's same as the viscosity. Well, here, I already brought, again, this one. The region that I brought here. This is what you need to do. Balance need to connect to the computer so that you can get the weight as a function of time. That's important. Weight as a function of time. So it has to be connected to the computer. Weight. I don't know whether you notice or not. This is more likely this chamber and capillary. So I'm going to give you detailed dimensions so that you can build. I don't know whether it's possible or not. I hope you could. Okay. That chamber is actually this one. This part. Understand? That's this one. This one is slurry. So yesterday what we did was to try to come up with some viscosity, but actually you can use it as the liquid filtration device. Constant weight, constant pressure, work, anything you can do with it. So this part right here is same as This one. Yeah. You have to build something like this on top of it. Then actually you can carry out your the liquid filtration testing equipment. So I'm giving you all the drawings. It's up to you to build the test rig. So this is actually what I did, experimental data. The lube oil 50W40 that I used it, and new oil, used oil, sample that I used microglass, melt-blown cellulose. So somehow I like to look at the all the characteristics. So shear viscosity and volumetric flow rate. This one we call it millipore pressure millipore holder. Actually, millipore pressure holder. I don't know whether this is commercially available right now. I doubt it. And then this is the final result. Yeah.
What was the full form of MFP?
Huh?
MFP.
Mean flow pore. Mean flow pore diameter. Mean flow pore diameter. There is equipment. You can buy it. It's about $20,000. Then you can get the mean flow pore right away. But how? Yes, mean flow pore is quite important for liquid filtration. Yeah, that's the starting testing equipment, mean flow pore. So here, microglass and melt blown and Q, you can measure it, right? You can measure that one. I don't know, say Q value, right of 0.2. But important thing is final result. Here, Q and time. So you can actually get some differentiation between used one and then some the additive 1 and additive 2. I don't know, it is not really interesting to you, may not be. So here, this is quite interesting result. Q times viscosity, then you can get all 4 different materials as one single line. Then you can get some conclusion out of it. So it's possible to measure shear viscosity of lube oil using millipore or pressure holder. Polymer 1 additive appear to be much more effective to reduce the viscosity than polymer 2. Flow rate through the melt-blown filter media was slightly increased at the higher pressure, even though the air pressure was increased 2 or 3 times. This is the issue. The melt-blown, if you pressurize a lot, then it's compressed. So that is the bad part of the melt-blown material. But well-blown is quite popular right now. I'm going to talk about that one in the sustainable filter media development. I believe this last slide that I have. However, I told you earlier, this is my expertise field. So I hope you could use in your field. But like I told you, you have a right to use that equation. It's big privilege. I don't know whether you notice or not. Yes, it does. Finish a little early.
You can discuss if you have any questions.
Well, here I really want you to study the material that I give you. So three of them, sometimes
Is there any equipment that prepares this like EPTFE? Is it commercially available? Yes. EPTFE is there. But EPTFE,
No, EPTFE is the next to that. EPTFE is also available, but there is no Indian manufacturer that we know. India basically imports the EPTFE membrane from abroad. Presently, we don't have any EPTFE system.
EPTFA, making EPTFA is not that easy. Somebody who knows about the process, then it's a lot easier. Well,
basically it is expanded to get the sufficient strength to the material. That is the basic idea.
Chose to make UHMW HDP membrane.
UHW.
Ultra high molecular weight, high density polyethylene membrane. What technique? It's
Same thing.
Or electrospray?
No. It's same stretch. Stretching. It's not that blown. It's stretching. Same as EPTFA. I can tell you. Well, it's recording, so I don't want to. Later.
Teflon, it is basically Teflon. But the thing is that it is in a, fibrous form. It is not a coated form. If it is a coated form, then the problem here that the pressure will be very high. That is why, that is the challenge again, how to make a membrane.